All right, so we're in Unit 1, which is actually Chapter 7 in your textbook for BC. And we are going to be moving into 7.4. So we are not going to cover 7.2 and 7.3 because they're not tested on the AP exam. Okay, so integration of rational functions by partial fractions. So I will integrate rational functions using the rule for partial fractions, and we're only going to do non-repeated linear factors. Now, before we get into integrating, let's talk about what are partial fractions to begin with. Okay, you've got to remember what that is from Algebra 2 and Pre-Cal. What are partial fractions? So what you did in Algebra 2 and Pre-Cal was you learned how to combine two rational expressions. So taking 2 divided by x minus 1 and subtracting 1 over x plus 2. You learned by a common denominator, right? So you did this. You said, okay, this guy's missing this factor here. This dude is missing the x plus 2. So we're going to multiply the top and the bottom by x plus 2. Then over here, this dude is missing the x minus 1. So we're going to multiply it by x minus 1 on top and bottom. So that gives these guys a common denominator. So your common denominator ends up multiplying out to be that, right? It's these two guys multiplied together. So then when you simplify this, this is 2x plus 4. And then over here, this is x minus 1, and we're subtracting. So 2x minus x is x. 4 minus negative 1 gives you 5, and you get this answer. So this is what you learned how to do in Algebra 2 and Pre-Cal, was you learned how to add and subtract rational expressions to combine them together to get one answer, one rational expression. Now, what we have to do is we're going to do the reverse. We have to undo that process. So we have to take this rational expression and break it up into what's called the two partial fractions, okay? So we're going to take this expression and break it up into what the two original rational fractions were, the functions, what those two things were before they were combined together to give you this one rational expression. So we're reversing it. So here's the process you do. You factor your common denominator, all right? So it'll be factorable, all right, with nice numbers. So you're going to factor your common denominator. Then you're going to write it as two separate fractions, and we always use addition, okay? You're going to write it as two separate fractions, one with one factor as the denominator and the other one with this other factor as the denominator. And then we're going to do algebra to figure out what the expressions A and B are. And what's going to end up happening in this problem, A is going to end up being 2, okay? And B is going to end up being negative 1. So B is going to end up being negative 1, so you end up with a minus 1 over x squared. So B is going to end up being negative 1, and A is going to end up being 2. So we're going to solve for A and B by algebra, by multiplying by the common denominator and doing some algebra. All right, so that's what we have to do. We have to take the rational expression and break it up into the two parts, or maybe sometimes it's 3 parts. So let's actually do this problem that I was just explaining through. So when you factor the bottom down here, again, 2 and 1, more positive in the middle. So it factors into that. So you break this up into two fractions. One of them has the x plus 2 denominator. The other one has the x minus 1 denominator. And you label them A and B. It doesn't matter which one is which. Makes no difference. All right. Now we're going to do algebra to solve for A and B. So here's what you do. We're going to multiply the entire equation by the common denominator. So you're going to multiply by x plus 2 and x minus 1. So you're going to multiply the whole expression, this whole thing. So when you multiply this first term, they all cancel, and you're going to be left with x plus 5. Okay? You're going to multiply both of these times this term. Well, the x plus 2's are going to cancel. So you're just going to have a times x minus 1. Then you're going to multiply this common denominator times this second term over here. So the x minus 1's are going to cancel. And you're left with b times x plus 2. And that's what happens every single time. You end up just having your numerator. It ends up being this term times this, and then it ends up being this term times that. That's what happens every single time. So you end up having your numerator equals this A times the denominator over here, and then the B times the denominator over on this side. And that happens every single time. So then you got this nice little fraction here. Okay, so now, well, not a fraction, but an expression, your algebra expression. So now we've got this equation that we can solve. Now here's the easy way you solve this. You pick numbers, values for x, and you're going to pick, important values of x. So what I'm going to do, I want to make the a go away. So what I'm going to do is I'm going to pick x to be 1. If x is 1, what does this expression end up equaling? All right, so I'm going to plug a 1 in everywhere. So if x is 1, that's going to be 6 equals, putting a 1 in here, this part's going to be 0. Putting a 1 in here is going to make this 3b. So right off the bat, I know the answer is B is 2. Okay? Then I'm going to pick another x value that's going to be convenient. Well, over here, I'm going to get rid of the b term. So if we conveniently pick x to be -2, and let's plug in -2 into this equation. So if I plug a -2 in here, I'm going to get 3. If I plug -2 in here, that's going to give me -3a. And of course, putting -2 in here is going to make that 0, so the b goes away. So then you're solving this equation. So you divide by -3 and you get a is -1, which we already knew from looking at this problem over here. Even though I had the letters reversed, it doesn't make any difference. One of the answers is 2, the other one is -1. So notice the 2 answer is above the x minus 1, and the -1 answer is above the x plus 2. So that should be the same thing over here. All right, my 2 answer is above my x minus 1, and my -1 answer is above my x plus 2. So what does that mean the answer is? That means my answer is -1 over the x plus 2 plus the b value, which was 2 over x minus 1. And you could have them reversed, it wouldn't make any difference. So that means x plus 5 over x squared plus x minus 2. That expression equals these two partial fractions, right? So that equals -1 over x plus 2 and 2 over x minus 1. And that's our answer. So we've done what we call the partial fraction decomposition. We took this and decompositioned it, whatever the word is for that. We decomposed it. That doesn't sound right. All right, we've done the decomposition. There we go. And that gave us these two partial fractions. So if you do a common denominator, multiply these all together, you're going to get this number, get that problem there. All right, so let's just do some more practice problems. Because that's the first thing you got to know how to do, is how to do this partial fraction stuff before you can even get to the point of integrating. Okay, so the first thing we're going to do is we're going to break this up into what this factors on the bottom. Well, I'll do that. I'll just do that underneath here. So this factors into x and x, and I need factors of 6 that give me 5 in the middle. Well, I can either do 6 and 1, or I can do 2 and 3. So we got to look at our signs to decide which one is the best. So we need to be able to multiply to get positive and add, so they both have to be negative to add to get negative, but multiply to give me positive. So now it wouldn't make sense to use 6 and 1, because when you add that, you get -7. I don't want -7 in the middle, so I need to use 2 and 3. So -2 times -3 gives me +6, and when you add them together, you get -5 in the middle. So now I write these as two fractions, one with x minus 3 in the denominator, the other with x minus 2 in the denominator. And I'll label this a and this is a b. And like I say, it doesn't matter if you reverse it, because if you've got these backwards, then your a number is going to be my b number, and my a number is going to be your b number. We're going to get the same answer. Okay, it's just our letters a and b will be backwards, but they will be above the correct linear function, so it'll be okay. All right, so that's the first thing you do. Now, we're going to multiply this whole entire thing by this common denominator. So we're going to multiply by x minus 3, x minus 2. So when you do that, multiply that times this first part, the denominator goes away, and you're left with x minus 4. Then over here, we're going to multiply it times this first fraction. Well, the x minus 3's cancel, so it's going to be a times x minus 2. And then we're going to multiply the common denominator times this rational expression. And so that makes the x minus 2's cancel. So that's going to give you b times x minus 3. Notice that pattern happened again. We were left with the numerator equals a times this denominator, and then b times this denominator. So that little pattern happened every time. Now, here's where we get to choose convenient numbers for x. Well, to get rid of the a here, I'm going to choose x to be 2. So now let's just plug a 2 in everywhere. So if I put a 2 here, that'll give me negative 2 equals, plugging a 2 in here makes that go away. Plug a 2 in here gives us negative 1b. So then when you divide by negative 1, you get the answer 2. So up here, b is 2. So now pick a number that's going to get rid of the b term over here. The b term is going to go away if x is 3. So let's plug 3 in the entire problem. So if I put a 3 in here, that'll give me negative 1 equals, plug a 3 in here, that'll give us a 1a. And of course, if you plug your 3 in here, that part's gone. So that just tells me a is negative 1. So up here, a is negative 1. So here's my answer. Negative 1 over x minus 3 and 2 over x minus 2. So I've done the partial fractions decomposition. All right, now I'm going to factor this one. Now this one's got a few more parts to it, so I got to show you how to do this. All right, so here we've got to factor out the x. So if I factor out an x, I'm going to be left with 2x squared plus 3x minus 2. That's just factoring out of x. And now I need to factor this quadratic here, which is going to be 2x and x. And I need to be 2 and 1. So 2 and 1. And I need to have more positive in the middle. So I need to have 4x's minus a 1x to give me a 3x in the middle. Now notice we've got 3 parts. So that means this breaks into 3 partial fractions. So one of them is going to have a denominator of x. Another one is going to have a denominator of 2x minus 1. Another one's going to have a denominator of x plus 2. All right? And then, so we're going to have an A, a B, and a C. So we're going to do the same thing. We're going to end up multiplying this whole problem by the common denominator x, 2x minus 1, and x plus 2. So I'm going to multiply everybody by that. So when you multiply this common denominator times this first dude here, the denominator goes away because that is my denominator down here that I factored. So I'm going to be left with x squared plus 2x minus 1, which is just my numerator. Now, when I multiply this common denominator by this first term here, only the x's are going to go away. So that means I'm going to have a times 2x minus 1 times an x plus 2. And then we're going to multiply this guy times this second term here. So that means the 2x minus 1s are going to cancel. So you're going to have b times x and then the x plus 2. And then you're going to multiply this common denominator. This common denominator times this third term. So the x plus 2s are going to cancel. So you're going to be left with c times x times the 2x minus 1. All right, so now this is our expression that we have. Now notice the pattern is the same. We were left with the numerator, and then a got multiplied by both of these guys. B got multiplied by both of those, and C got multiplied by both of these. So notice the pattern worked the same. So the A, B, and the C got multiplied by whoever they didn't have as denominator. Okay, is the best way to phrase that. So A got multiplied by the 2 that was not his denominator. The B ended up getting multiplied by the 2 terms that was not his denominator, and the C is multiplied by the 2 terms that's not his denominator. All right, that happens every time. So now, again, we're going to do the same thing. We're going to conveniently choose what our x is going to be, okay? So I'm going to conveniently, let's get rid of the a first. So to conveniently get rid of this a right here, I could make x -2. Okay, so if I make x -2, then I'm going to plug a -2 into this first. I'm just plugging -2 into everybody, actually. But I'm going to plug a -2 here into this first term. So -2 in here is going to make 4. -2 in here is going to make -4. So they're going to cancel. So that's going to leave me with a -1 equals. So now if I plug -2 in here, that's going to make this term 0. So a is going to go away. If I plug -2 in here, notice -2 is going to make this 0. So the b is going to go away. So the only term I'm going to have left is the c. And I have to plug in -2 for these x's here. So that's going to be a -2. And then -2 in here is going to make -4 minus 1 be -5. So I plugged a -2 in here, and then I plugged a -2 in there to make, and it gave me -5. So I'm ending up with -1 equals 10c. Yep, that's a 10c. And so c is -1/10. That's the answer for C. And that's what you want to keep. You don't want to try to fix it or do anything to it. All right, now let's pick another convenient value of x. All right, let's make the b go away. Well, we did that before, but let's pick a different number. I can make x 0. All right, if x is 0, let's see what happens. So if I put a 0 in for all my x's, I'm going to be left with -1 equals. Putting in a 0 in for my x's here is going to leave me with a times a 0 in here is going to make a -1, and a 0 in here is going to make a 2. And then notice if you put a 0 here, the b goes away, and if you put a 0 in here, the c goes away. So this is the only equation I have. So I've got -1 equals -2a. So if I divide by -2, the answer is 1/2 for a. And so now what's our last number that we need to conveniently make x equal to? Well, that's going to be the part that makes 2x minus 1 0, which would be 1/2. So let's make x 1/2. So if we put a 1/2 in here, 1/2 squared is a 1/4. Put a 1/2 in here, that's going to be 1, and 1 minus 1 goes away. So the answer is just going to be 1/4. If you put a 1/2 in here, that makes this go away because that's going to be 0. And the same thing's going to happen with the c. If you put a 1/2 in here, that makes that go away. So the only term we're going to have left is the b one. So this will be b times, I'm putting a 1/2 in there, so 1/2, and then putting a 1/2 in here. 1/2 plus 2 is going to be 5/2, or 2.5, however you want to put it. All right, so 1/4 is going to equal b times 5/4. And then to get rid of the 5/4, I'm going to multiply by 4/5. So b equals 1/5. So that means up here in this problem, all right, that means up there in that problem, my a, this is a 1/2 there, b is a 1/5, and c is a -1/10. And you can just leave them like that. They can stay exactly like that. Those fractions, it's not a big deal. So our a was 1/2, our b was 1/5, and our c was -1/10. And so that's our answer, those fractions over those linear factors. All righty, we're just learning to do the partial fraction decomposition. And it's a straightforward algebraic process every single time. All right, we're going to factor this denominator, so I'm going to pull out an x. That'll leave me with x squared minus 1, and then I'm going to factor that term into x plus 1, x minus 1. All right, so I'm going to set this equal to those three fractions using these denominators. So x, x plus 1, and x minus 1, and then I'm going to call these a, b, and c. All right, so what you're going to do is you're going to multiply this whole problem by this common denominator, x, x plus 1, x minus 1. But what happens is you end up with this numerator, x squared plus 2x minus 1 equals. And then for here, the a ends up getting multiplied by both of those. So a ends up getting multiplied by x plus 1, x minus 1. The b gets multiplied by these other two. So b gets multiplied by x and x minus 1. This is the pattern. It happens every time. And then the c gets multiplied by these two denominators, x and x plus 1. All right? And so that's what we end up getting. So now we conveniently choose what we want x to be. So if I want to get rid of this a term, I could make x positive 1 because that would make this term 0. I'm just going to do that one because that would be negative. So I'm going to pick this one. X, if x is 1, that means this is going to be 0. A is going to go away. So now let's plug a 1 into everything. So if we plug a 1 in here, we're going to have 1 plus 2 minus 1, which will be 2. And then we say we're putting a 1 in here, so that makes that 0. Same thing's going to happen here. You put a 1 in, that's going to make this 0, so B is going to go away. So the only thing we're going to have left is C, and we're plugging a 1 in here, so that'd be C times 1 times 2, so that's just a 2C. And then when we divide by 2, we get C as 1. So up here, this C is a 1. Now let's conveniently choose, let's choose x to be negative 1. We've got to eventually do it. So if x is negative 1, plug a negative 1 in over here. So negative 1 squared is going to be 1. And then negative 1 in here is a negative 2. So we have 1 minus 2 minus 1. So that's going to give us negative 2. Putting negative 1 in here makes a go away. And of course, putting negative 1 in over here makes the c go away. So the only one we have left is the b term. So putting a negative 1 in here is going to make it negative 1 times negative 2. So that's just going to be 2. So I'm plugging a negative 1 in here. So negative 1, and then here will be negative 1 minus 1 be negative 2. So negative 1 times negative 2 is a positive 2. So I'm going to be left with b times 2. So when I divide by 2, b is negative 1. So up here, this is a negative 1 there. And then the last one, we're going to do x is 0 because that would get rid of the b term and the c term because we already know what b and c are. So if x is 0, now plug a 0 into everybody. So if we put a 0 into everybody over here, we're left with negative 1. We already know putting a 0 here makes the b and the c go away, so we're only going to be left with the a term. We're putting in a 0. So if I plug a 0 in here, I'm left with 1. If I plug a 0 in here, I'm left with negative 1. So 1 times negative 1 is negative 1. So we're going to have a negative 1a. So if we divide by negative 1 on both sides, a is going to be 1. And so up here, a is 1. So there's your answer. 1 over x minus 1 over x plus 1 plus 1 over x minus 1. All right, so that works out just perfect, perfect, perfect. So this is called partial fraction decomposition. All right, so now before we get into what we're going to do next class, we know how to do partial fraction decomposition. Now, why are we learning partial fraction decomposition? Because you are going to have to do this kind of problem. You're going to have to do the integral of that first problem we started with. So you're going to need to rewrite him as that partial fraction decomposition that we got, which we might have got plus negative 1 over x plus 2. All right, so that's what you do. You rewrite it. Let me make it neater so we can follow along. All right, you're rewriting this as a partial decomposition, okay? Partial fraction decomposition, which makes these antiderivatives extremely easy. So let's do a quick integration review for Ln, okay? These are all going to be Ln problems. So anytime you have a variable in the bottom and one not in the top, and these are all going to be linear, it's all going to be a Ln of your denominator. And then your numerator is just going to be your coefficient. Because remember, the derivative of Ln is the derivative of the bottom over the bottom. So the derivative, since we got linear factors down here, the derivative is always going to be 1. So if you don't have a 1 up here in the numerator, then that's going to be your coefficient. So the integral for this is just going to be 2 times the natural log of x minus 1 minus, and since this is a 1, it's just going to be the natural log of x plus 2. All right, and then plus c, and I'm done. That's my answer. So you just need to make sure you remember how to do integrating ln. Okay, so if I integrate ln, let's say I had 5 over x minus 4 plus 2 over x dx. All right. Well, this is just going to be 5 ln x minus 4 plus 2 ln x plus c. That's all it's going to be. Because remember, the derivative of ln is the derivative of the function over the function. And then you just have to times by 5 to get this answer up here. And the derivative of ln of x is the derivative of x over x. And we just have to multiply by 2 to get this expression up here. So these are going to be extremely easy to integrate. So this was the hard video to watch. Your next video doing the integrals is going to be the easy video to watch. All right, it'll be the simple one because we've done the hard part. All right, so you do have a worksheet with a couple problems on it that I want you to practice doing the partial fraction decomposition before you watch the next video. Just get comfortable with doing this algebra before we get into doing the integration of partial fractions.